So the last video I'm going to demonstrate that how we can use the knowledge on the distribution to answer more meaningful questions. Okay, hey, we have a bunch of numbers and then we're turning it into the shape, and then what? Okay, so we can calculate the probability. So that's why we're here. Again, this data shows you the summary of last 1,000 year average September temperature in Toledo to your left and Bowling Green to your right. The same story, right? Bowling Green has much smaller spread, okay? Therefore makes the prediction on the Bowling Green weather relatively easier than predicting the Toledo weather. Toledo weather has much greater spread, okay? It's spreading all over the place, starting from somewhere sub 40 all the way to above 120, okay? But that is not the case with the Bowling Green. What kind of information tells you that? You know, of course, visual inspection can tell you that, but we can rely on the standard deviation. So here, descriptive statistics shows you the same story. Average 76, 77. Okay, you have a one. You had almost 1 or 2 Fahrenheit difference here, and in terms of standard deviation, the difference is much bigger. Toledo is 3 times higher than the Bowling Green. Okay, so some of you may have noticed that this result is not exactly the same with the previous example, because this is because I'm relying on a simulation random number basis simulation. So each time I open this up, it will give me slightly different result. But the parameter setup I used is trying to make the Toledo have 3 times of the standard deviation when compared to the Bowling Green. So that in general, these are the similar. Okay. So later I may provide you this data. You can take a look at this by yourself. Another piece of information you need to looking for here is the shape of distribution roughly resembles this fit line. The fit line shows a perfect bell curve, okay, perfect normal curve here. So the story here is that, hey, the Toledo weather distribution follows bell curve, okay, although it's not perfectly fitting in with a bell curve, it roughly resembles a bell curve. Don't worry too much, okay? The perfect bell curve does not exist anywhere. Perfect bell curve is just a theoretical curve that statisticians use to obtain a reasonable estimate. Okay, you cannot find perfect bell curve shaped things anywhere in the world. The same case with Bowling Green. You see these part, okay, these part especially high, but don't worry too much. Later I'm going to show you the result, okay, which implies that these discrepancies doesn't actually influence too much to the result. Okay. So my question here is, what is the chance that the average temperature during September is less than, I should say is lower than, okay, poor English, is lower than 65 Fahrenheit, or you can write it in this fashion. X represents the temperature and the temperature is less than 65. So this way of saying it is much more parsimonious, much more compact, concise. If you can use that, I strongly recommend you to use that, okay, instead of saying long sentence. So the question here is, what is the probability that the average temperature during September is lower than 65 Fahrenheit in both locations? Okay, so any clue how you can answer this question? So if you want to try something, you can pause and try something by yourself. But if you have no clue, I can offer some explanations here. Okay, but the good thing in converting number into a shape is that we can actually use some knowledges in geometry and calculus and use those to calculate the probability. Okay, let me show you what I mean by that. So you don't really have to do any calculus, but anyway, I'm trying to demonstrate how we can do this. So here is the Toledo curve. Okay, so my question was, what is the probability of temperature lower than 65? Okay, so I will draw a reference line here. So 70 will be here, 75 will be somewhere here. So I'm going to draw a reference line like this. So assumption here is that we're assuming that weather in next year will not change dramatically from its previous pattern. Okay, so in other words, we do not assume global warming or any other global temperature changes into the consideration. Nothing political, nothing environmental, it's just for the convenience of calculation. Okay, so if the same weather pattern repeats again this year and forward, it is very likely the weather will follow the previous 1,000-year pattern, which is presented in front of the screen here, in front of you through the screen right here. So I draw a reference line. So my question was, what is the probability of weather being less than 65 Fahrenheit degree? So 65 is here. So if you can identify the area that fit into our description, it will be the area that is left to this reference line. Okay, so this line and this curve almost shape a triangular shape. It's not exactly triangular, but let's imagine if it's a triangular shaped. Can you calculate the average? I'm sorry, can you calculate the dimension? Of course you can, right? Of course you can do that. That's the concept right here. The area under the curve is the probability we are trying to calculate. So that is one advantage of turning your number into shape, okay? Your shape into curve, and under the curve area is the probability. So as long as you can calculate area under the curve, we can go back and answer this question easily. What is the chance that the average temperature during September is lower than 65 Fahrenheit in both locations? So it's very easy. In fact, if you use Excel as a calculation tool, you can just feed in this formula into Excel. Okay, let me do it. The first calculation is for Toledo. Okay, Toledo, temperature less than 65. Let's calculate this formula and open your Excel. Punch equal symbol and paste. Boom. So it's 24%. Okay, let's go back and see if I got the result correct. Yeah, because I calculated already. So this is the probability that weather is going to be less than 65. Okay, so this is you can repeat the same process. So this one is the threshold in question, which is 65, and this is your average. This is your standard deviation. The true is constant. It has to be there as a true always. Okay, so you do the same. You repeat. You can get probability that is much smaller than the Toledo probability. Okay, so yeah, in order to help you understand a little better, let me open up my STAT website one more time. So again, this is from, let me see, okay, this is a website I want to open. So again, we'll go back to the Art of Stat. If you scroll down in the middle, you'll see the normal distribution tool. You click it. You go to the second tab, find probability. Let me see. Okay, this is our file. So the average is 7609A05. Okay, standard deviation is 16.01886. Okay, the value of x is 65. Okay, so this tool also gives you the same result. Much better, it kind of gives you a graphical representation of the area which we're interested in. Okay, so area under the curve, which is the left to the 65. So this is the probability we are trying to obtain. So can I say, then what is the chance that probability is larger than 85? Okay, you can utilize this tool, or you can go back and utilize Excel, but I will try this first. Okay, so upper tail, we're looking for upper tail and 85. This gives you the probability, which is 28. Okay, the one thing you need to remember is that the Excel tool only gives you the area to the left. Unlike this tool, it can give you both direction. Excel can only tell you the direction to the left of the reference point. So you can actually do a workaround, right? So you can change this number. You can change this number into 85, right? Other parameters remain the same. So what you can do is actually 1 minus this value, 28, okay? Which is the same, I deleted it, which is the same with this result. Okay, so this gives you probability that temperature being larger than 85 for the Toledo area. Okay, so let me write down what I did in Excel. P Toledo, temperature larger than 85 is 1 minus repeat it, which is 2A92. Okay, A92, 85 again. Okay, let's make it subscript. So yeah, this is how you can obtain so-called more meaningful question based on the distribution you have. So is this result reliable, right? Is this result reliable? I think you always wanted to know, right? So my ensuing question here, we can cross-examine the solution here. Okay, maybe we can pull it down here because this is just a reference. Okay, so we can cross-examine this result, 24% and less than 1%, to compare this result with the data. So what I did here is I counted all the incidents from previous 1,000 year. How many times temperature was lower than 65? It was 247. It's 247 out of 1,000. Okay, so I'm doing this in order to confirm whether this result is reliable or not. Okay, so here this is 24%. Here is 24.7%. This is 24.4%. A slight difference, but the difference is not that huge. Okay, so this is actually a pretty good estimate of the probability we're trying to get. The same thing with the Bowling Green, although in this case it's 0.1%, in this case it's 0.6%. Again, the difference is less than 1%. Therefore, I think this result is acceptable. Okay, so yeah, this video is kind of long. I try to demonstrate how you can utilize the knowledge on the distribution. Okay, so basically 3 things are important: mean, standard deviation, and the shape. So if the shape is not normal, we have to use a different set of formula, okay, which we can discuss later. But in this case, I have demonstrated how to use normal distribution to get the result. And the question we will ask is the chance of the average temperature during September is lower than 65 Fahrenheit in both locations, which we got the solution here. We confirmed with the record, and the record says that this result seems to be plausible. So the answer you can offer is that as long as Toledo weather or Bowling Green weather does not change their pattern dramatically, the chance of weather less than 65 Fahrenheit degree is 24% in Toledo and 0.6% in Bowling Green. Okay.